Deep Silicon VLSI YouTube channel. In this video, we are going to learn about hexadecimal addition. Yes, let's dive into the question directly. Question number 35. The addition of two numbers 1a8 base 16 plus 67b base 16 will be 889, 832, 823, 723 base 16. Guys, for this hexadecimal addition, there are different methods. Let's start method 1. Guys, here 1a8 is there. Why don't you convert this 1a8 into decimal, like 8 into 16 power 0, a into 16 power 1, 1 into 2, like 16 power 2. If you do that, we will get 424 base 10. Similarly, you convert this 67b base 16 into decimal form, then it is 1659. What they told, you need to add this, right? Then you need to add this. Therefore, here 424, 1659, 13, 8, 10, 2, 2083. So again we got 2083. Now we got in the decimal. Again you convert this into hexadecimal, like 16, like 2083 format. Again you convert and you will get the answer as 823 base 16. Then we can tell option C is the right answer. Yes, this is the method 1. Even though they asked for hexadecimal addition, we went to decimal, we added in decimal format, again we came back to hexadecimal. However, it requires more computations, more efforts it seems. Then what is method 2? Let us take method 2. It is in hexadecimal form. Why don't you convert into decimal? It's 1. Like in binary 0001, A 1010, 8 1000. Similarly 67B 0110, 0111, 1011. Now you add this. Therefore you get 1 1 0 0 carry 1, 0 carry 1, 1 carry 1, 0 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 carry 1, and it is 1. Therefore, if you convert this into hexadecimal, then it is 8, 2, 3 in hexadecimal form. So in this way also you can do it. In method 1, you are going to the decimal and you are coming back. Method 2, you are doing in binary way. You are going from hexadecimal to binary, and again you are doing the addition, and again you are coming back to hexadecimal. However, guys, we have method 3, that is hexadecimal addition only. Why are you going to some other number system? No, they asked you hexadecimal addition. Why don't you do it as it is? Now, let us take this hexadecimal addition, for example, that is method 3. Okay. In method 3, we are doing the hexadecimal addition directly. Let's take 1a8, 67b. Therefore, guys, 8 into 8 plus b. What is b? 11. 11 plus 8, 19. 19 in hexadecimal, guys. Obviously, it is 1 3 because 1 into 16 power 1, 16. 3 into 16 power 0, 16 plus 3, 19 only. So it's 1 3. Again, a plus 7 plus 1. A means 10, 7 plus 1, 8, 10 plus 8, 18, 18 in hexadecimal, 1, 2, 1, 2. Similarly, 6 plus 1 plus 1, 8. So it's 8 to 3, base 16. Hence, the answer is option C, 8 to 3, base 16. Hence, guys, what we want to tell you is, every problem has different solutions, but you need to choose The easiest one to save your time. Got it? Let's see hexadecimal subtraction. Guys, here the question is number 36. Which of the following subtraction operations results in f base 16? BA minus AB, BC minus CB, CB minus BC. Guys, here the hexadecimal subtraction. Let's dive into the solution. We are taking directly the hexadecimal subtraction only. So that BA, AB. Guys, obviously now A minus B, 10 minus 11, not possible. Then we will take credit from the next digit. If it is the decimal, we will get 10. But it is a hexadecimal, right? Hence you will get 16. 16 plus 10. How much? It is 26. 26 minus 11. Then you will get here 15. Isn't it? Yes. So 15 in hexadecimal. F. Again, from B1 already went. Then you get only 10 only. 10 minus 10. Then it is 0 only. It's a 0F. 0F obviously is the result. Hence, this is giving it. Option 1. Like 1 is giving it. Again, you take this BC minus CB. If you take BC minus CB. When you do this, guys, again, you get C minus B. What is that? Here 12 minus 11, 1. Then again, B minus C. B minus C is not possible. Here, if you want to perform what is the right answer, then again you need to take this into binary, applying the 2's complement for this and getting the answer. Obviously, it is a little bigger process. For that, what you can do is, instead you can go to decimal. BC in decimal, CB in decimal. Therefore, it is this one 188 base 10 and this one 203 base 10. Then guys, definitely you will not get F16, F base 16. You will get some negative value. Hence guys, this will not give you the F base 16. Then third one, CB minus BC. CB, BC. Now the same. B minus C not possible. We will take the credit from the upper digit. Therefore, B means 11. 11 plus 2 like 16. It is 27. 27 minus C. C means 12. 27 minus 12. How much you get, guys? 15. 15 in hexadecimal form. F. Then guys, already from C, like one digit went, then it is B. B minus B, 0. So 0F base 16. Hence, the third one, CB minus BC, is also giving F16 as the result. Hence guys, we can say that from the three options, which statements are giving F16 is none other than 1 and 3. Hence, from the options, the right answer is option B. Only 1 and 3. In this way, guys, you need to know every method so that you can reach the answer as early as possible. I hope you like this video. For more interesting updates, please subscribe our YouTube channel Deep Silicon VLSI. See you soon in the next video. This is Shivram signing off. Jai Hind.